esteemed guests. Energy and climate are two of the most pressing challenges of our time, intricately linked in shaping the future of our planet as global energy demands continue to show that reliance on traditional energy sources has led to significant environmental consequences, escalating climate change and threatening ecosystems worldwide. Today's panel discussion will delve into the critical needs for innovation solutions, focusing on clean energy transitions, policy reform, and sustainable practices. Please join me in welcoming Dr. Mishra, Director in Charge, Center for UG and PG Studies, BPUT, Raulkela, and an expert in power system and smart grids, as the moderator for today's panel discussion. So, please join us on the stage. It's my privilege to invite a well-refined CEO and co-founder of Drubus Technology, Mr.Swroop Mohapatra, with 20 years of experience in IT solution. Please welcome him with a round of applause. It's my absolute honor to invite Mr. Bibhu Swain, a power system expert from IISc Bangalore and certified energy auditor. Please join us, sir. Our next panelist is Dr. Manas Ranjan Nayak, Professor and Head of the Department Electrical Engineering, BPUT, Raulkela. Sir, kindly join us on the stage. Now, I will request Dr. Sivkumar Mishra, sir, the moderator for the session, to take it forward.
You didn't invite Professor Dev.
I'm sorry. Please allow me to introduce our panelist, Dr. Alok Kanti Dev from Indian Institute of Technology, Kharagpur. Sir, please join us on the stage.
Good morning. Okay, let me first apologize the students. This is Sunday morning. You have all come. Thanks for attending this session. Distinguished guests on and off the dash, esteemed panelists and members of the audience. Today's audience include senior persons from industry, principals, directors of various affiliated colleges of BPUT Odisha, senior faculty members and students from these colleges, and of course faculty members and students of the campus college of this university, CUPGS, Center for UG and PG Studies. It's an honor to welcome you all to this panel discussion on energy and climate. It's a critical topic under the broader theme of this conclave. The broader theme is, as you can see, sustainable education towards Viksit Bharat, the role of BPUT Odisha. So this is the theme of this particular conclave, that is BPUT Industry Academia Conclave. We have invited a panel of industrialists, industry persons, persons from academia, and yesterday we had 3 sessions, and today we have already completed 1 session, and this is the 2nd session of today's. So, before going to the topic, I would like to ask you a very simple question that about a particular word that is being uttered, here again, that is, sustainability. Okay, so what does that word sustainability actually mean? Can anyone from the audience, particularly from students, I would like to have an answer from the students, that what is this word sustainability or sustainable mean? Why you are emphasizing so much on this particular word, sustainability? Yes? Any answer from the audience? This is very important. We have been talking so much about the word sustainability, sustainable education, sustainable food, sustainable this, that. But what is the word sustainable actually mean? Yes.
A very good morning, everyone. Myself, Afsana Pradhan from SIPET, Bhubaneswar. So, sustainability means using the resources we have right now in such a way that our future generation is also able to use it. We don't use it in such a way that it is consumed completely. That is sustainability.
That's very good. Actually, I'm happy that at least one student could answer this. Okay, because this session, unless until it is going to be interactive, it will not have any consequences. Okay, so thank you for that. The word actually sustainability refers to the ability to maintain or support a process, activity or system over the long term without causing harm or depletion to the environment, society or economy. It emphasizes balancing current needs while ensuring future generation can meet their own needs. That's what exactly she said. So if you sum it up, in essence, sustainability is about meeting today's needs without compromising the ability of future generation to meet theirs. That's very important. We should not be only worried about ourselves. We should not be selfish. We should also think about our future generation. We should develop, we should invent, we should innovate in such a way that whatever we innovate or invent or design, that should be sustainable, that should be usable for the generation to come. So that's what sustainability is all about. So driving that from the sense that sustainable education, we have to frame a sustainable education. And what is the bigger aim? Our Prime Minister has set a target before us that by 2047 we should be called as Viksit Bharat. Prior to that, we have another goal. As far as Odisha is concerned, it should be Viksit Odisha. And as you all know, that there are 17 Sustainable Development Goals, SDGs. I think our Vice Chancellor was, on the very first day, he was describing about these goals one by one. Okay, out of that 17, 3 such goals are relevant to this energy and climate. So, as we stand at the crossroads of a rapidly evolving world, the dual challenges of energy sustainability and climate change demand urgent attention. These are the two things. Let me repeat. The dual challenges of energy sustainability and climate change demand urgent attention. So today our discussion will center around how universities, industries and communities, related communities, can collaboratively address these challenges and pave the way for a sustainable future. So actually I was reading a article written by UGC chairman Professor Jagdish Kumar, and what he was telling that the NEP, the National Education Policy 2020, it was designed in such a way to achieve this. And what the role of the universities to align their curriculum in line with that NEP 2020. So for example, we have certain things, the role of higher educational institutes in sustainability. Number one, we can align with NEP 2020 and the SDGs, the Sustainable Development Goals. Particularly, if you could talk about energy and climate, we have four related development goals. That is SDG 11, Sustainable Cities and Communities. SDG 12, that is Responsible Consumption and Production. SDG 13, that is about climate action. And SDG 15, about life on land. I think we also should discuss about carbon neutral campuses. This is another area where we should also discuss. We should also discuss about practical and interdisciplinary learning with respect to energy and climate, community collaboration, and finally, we should have a longer vision which is in line with that 2047 Viksit Bharat vision. It should be, the universities should be hubs of eco-conscious living, environmental leaders, and we should contribute to a resilient and sustainable future. So, we have with us as the first panelist, Professor Alok Kanti Dev, who is a professor in electrical engineering in IIT Kharagpur. So I would like to invite him for today's first deliberation, that he would be mainly telling about the educational part, because he is from IIT Kharagpur. He can always tell us about the related research which is going on related to this particular field, and what the universities can actually do so that it will be in line with NEP 2020, so that we can achieve those SDGs and of course the greater goal of Viksit Odisha and Viksit Bharat. Now it's over to Professor Alok Kanti Dev to have his presentation and his views. Sir.
Good morning, Professor Mishra, other panelists, the audience, professors from different institutes, the students from different institutes. So it is my role to lead this session on energy and climate. Initially, I didn't think to make a presentation, but once I arrived yesterday and seeing this magnificent auditorium, I thought I should make a presentation. And with some little effort in the morning, I could make a presentation. Okay, so as Professor Mishra already introduced, I am from the Department of Electrical Engineering, IIT Kharagpur. I teach electrical engineering, do research, a lot of projects, industrial projects. I have done academic projects. And though I am a professor, I have actually worked in industry for 3 years. Before just immediately after my graduation, I worked in the power companies for 3 years, so I am not just a conventional professor, so I also have the industrial outlook, and I like to do industrial projects also. So today the topic is on energy and climate, so I just create the background that there is a UN Intergovernmental Panel on Climate Change, that all global pathways that limit warming to 1.5 degrees centigrade, it actually involve rapid and deep, in most cases, immediate GHG emission. Okay, so that is actually, we have to reduce the emission of fossil fuels in all the sectors. Greenhouse gas emissions. Now this main cause of this human activity induced global warming, it includes the areas of emission of CO2, methane, N2O, carbon monoxide, volatile organic compounds, and even black carbon. And its adverse effects are already felt. There is an increasing risk of crossing the tipping point. Already we have reached some threshold, and effects are already felt such that, there is the chance of melting of the Greenland and Antarctic ice in the Himalayas. The Amazon rainforests are getting affected, the Atlantic and Southern ocean circulations. And the effects we are already seeing that in, every year there are, in every 2 months there is one cyclone coming. In our own country, we see in the media how the states like Kerala and Tamil Nadu get devastated, the Uttarakhand state gets devastated by flash floods, and the huge amount of rainfall that sometimes happens in these big cities which are not planned for that. So already these are actually the effects of the greenhouse emission, and it has reached the tipping point. Now there is the role of industry, academia and administrators to avoid this climate change. Yesterday it was mentioned that this conclave is of industry and academia, but there is a huge role for the administrators because they have to frame the policies, they have to frame the laws, and they have to actually implement what is to be done in the correct manner. So at the current rate of global warming, so the way the global warming is taking place, already there is a 1.5 degree centigrade rise in temperature. So it is, if this rate continues, it is going to reach 3 degrees centigrade by the end of the century. Now the risk from climate change, there an increase in hot extremes, hot weather, we have extraordinarily hot weather in summer. Last few years we have seen the heat waves blowing, and we think that it is all natural, but it is all man-made. An increase in heavy precipitation happens in many areas. An increase in wildfires. Wildfires, because of this heat, wildfires, the forests catch fire. If you have seen the media, US is struggling to control their wildfire in the California state. And there have been casualties, and even their US president visited to see how they are fighting the wildfires. We have wildfires in our country, they have wildfires in other continents, Australia, Africa, everywhere, and this number of wildfires have increased. There is increase in droughts. Many of our Indian states, face drought. There is loss of cultivation, there is, farmer suicides, many other after effects happen. Increased scarcity of food and water. So these are the two things that sustain us, food and water. And when I teach this subject, I tell my students the next thing that sustains, that is required for sustenance is basically energy. There is a chance of ocean acidification, sea level rise. Sea level is already rising because of this global warming, and we have seen how the coastal areas are getting affected, and if it crosses certain threshold, many of those, we may even lose some landmass. Now there is a huge role of population growth in this requirement of energy and the effect on the climate. The climate change is happening around the world with increased frequency and magnitude of extreme weather conditions. The future evolution of the climate depend on how human behavior and policies will affect the natural systems. Obviously, this nature is affected by human policies, our behavior, and how we, control the different systems. Current human population is 8.1 billion, which is expected to grow to 9.5 billion. There is no reducing trend, it is increasing. And whatever situation we are having now, if we don't take proper measures, it is actually going to worsen. And much of this population increase is actually going to take place in our continent, Asia, Africa, South America. Okay, these are large continents. These are, all the developing countries are located here. Many people are not educated, so much of this population growth will actually going to take place. Now, even though the population grows, we all aspire for higher standards of living, and we need food, energy, and water for our security. Now, this demand for energy, water, food, as the urban cities develop, we will need more cement, metals, and the other resources are also expected to rise because we are building new cities. The population, the growth will need new shelters, and ultimately, everybody needs energy. And energy requirement is not just in terms of just light and fan. We all have different gadgets. We are becoming modern. We operate different gadgets, different equipments. Like there is a lot of new industries coming up, and they actually need energy. Now, very strong measures are required to meet these demands to avoid further climate change. As I told, climate is already changing. We are seeing the effect, the heat waves. We are seeing sometimes unnatural amount of rainfalls, and then their after effects. So if strong measures are not taken, the climate change, a permanent climate change cannot be prevented. Now this is basically a picture which actually shows the different things, how our life operates. We have the electrical energy systems, there is requirement of water, every city has all these things. There is requirement of food, agriculture, there is need of transportation. We travel by railways, roadways, now all modern cities have metro railways, then there is air travel, then there are the, people reside in homes, buildings, there are offices, the institutes, infrastructure, and that is how, the entire community is. And ultimately we have a lot of industries that produce different types of, components, and that is how our entire community is. We cannot get rid of them, any one of them, and we need actually all of them. Now, to control all these things, lot of engineering is required. All of you are engineers here of different streams, and in fact, that was also the discussion yesterday, that this is the age of interdisciplinary engineering. All branches of engineering required. There is a lot of requirement of mathematics, and so these are basically the different types of domains or engineering domains that are required to control this climate adaptation and mitigation. Like there is a lot of requirement of optimization, modeling and simulation, hydrogen storage, negative emission technology. That is, even if we can develop some technology to counter the emissions, distributed control, it is not just from somewhere the controlling has to be done, controlling has to be distributed in space. Then the sensing and estimation, all the physical quantities that are generated may need to be sensed, and then something that cannot be measured can be estimated. So these are the different things. Similarly, environmental monitoring. In the previous session, there was a discussion on if environmental monitoring or environmental subjects can be introduced even in the curriculum. Then there is ultimately everything affects the economy and the policy making, and ultimately the system identity. So these are the different subjects that are required to understand how the system operates, and then the ultimate objective is to control the climate. Now this is just a brief idea about the different ways of generating energy. We are all used to the conventional way of energy generation, the thermal power plants. India has abundant coal, and we have a lot of thermal power plants. All of you have seen a thermal power plant with these chimneys. Similarly, the other way of generation, conventional generation, hydel power station, wherever you have the high head of water, we can generate power by allowing that water to pass through some turbine. Then we have the other modern method of power generation, which is the nuclear power plant, where you have to burn nuclear fuel. to produce steam and then ultimately run a turbine and generate power which is available in our household. So these are the basically bulk power generators. Currently we also have the renewable power generations, there is the wind farms are there. If you have visited the places where the wind farms are there in our country, there are large wind farms in the Rajasthan deserts, Jaisalmer. There are some wind farms in the western part of the country, in the south, where you have this type of structure. Similarly, we have the other way of power generation, which is the solar. Many institutes and the government is actually patronizing to install solar power plants wherever there is vacant land, on the rooftops, on the top of the domestic buildings, everywhere the solar power is being installed and is pumped into the grid. Now, I just want to share the installed capacity of India. As I told, though this is a little bit old data, I could not get the data of this year. So this is the data of 2018, just before the pandemic, where 57% of the power generated in India is coal-based. Then we have large hydro plants. We have, in your state, Odisha, we have a big hydel power station in Hirakud. Similarly, there are small hydros, there are wind power, there is a solar power, 6% biomass, and then there is a nuclear power, and then gas-based power stations. Now, the purpose of showing this figure is, I actually use this same slide in the class. So this is basically the generating capacity, installed capacity. It was the installed capacity 2018, maybe the numbers are revised now. Some values will be high. Now what actually happens in our country, there is a huge amount of loss. And that number is so staggering, I always try to share that figure with my students so that even if we can just save that power, it is a big contribution to the society. So the wastage in our country just in government installations, if you like government installations means government offices, railway stations, it is like 1 lakh megawatt. You see that so much effort is made to generate power, but just 1 lakh megawatt is just a loss. You may find some power installed in the railway platforms, on during the daytime in government offices, some street lights are on in the municipalities, and that is the wastage. And that is again, this 1 lakh megawatt is a poor earlier figure, some maybe 10-year-old figure, and that number may also have increased. So the point that I want to mention, I try to develop this consciousness is if we can just put some effort even just to save this power, which is quite high, 1 lakh megawatt in our country. So we can conclude that energy saved is energy generated. And if you just save this amount of energy, you are basically you are generating energy. So, and it also results in reduction of utilization of fossil fuel, which reduces atmospheric pollution. So bulk of the power in our country is generated by burning fossil fuel, coal, oil, gas, and which actually leads to production of those gases, CO2, CO, N2O, and they actually create atmospheric pollution. So if we can reduce the fossil fuel generation, you are basically contributing to saving the atmosphere. So one of the targets is to generate, there is also a new form of energy generation which is use of hydrogen in carbon-free energy systems. So hydrogen has been found to be another alternative. So if you have the existing grid and if you have the hydrogen which can be used to ply hydrogen vehicles, hydrogen can be used for generating furniture, fertilizer, metal refining, then heating, synthetic fuels. Now this hydrogen can also be used for power generation, and hydrogen is available in bulk in our atmosphere. We have a lot of water, we have a lot of seawater. If we can utilize it for power generation, we can reduce our dependence on the fossil fuels. And because our grid is interconnected, our entire country is connected, so anywhere you can generate power, you can put it back to the grid and you can reduce the fossil fuel utilization. So there is a roadmap to the net zero greenhouse gas emission by 2050. It is an international roadmap where they have done, shown is from 2021 and then over the years 2025, 2030, 2035 and all. Gradually they will reduce the low emission sources like the fossil fuels. They will use the electric vehicles, okay, and gradually by 2050 it should achieve a net zero emission. That is entirely the greenhouse gas emission should be made zero. And if that is the situation, then we can actually control the climate. Now there is another, dilemma. As I am told, I am an electrical engineer. Is the current grid is all AC. Bulk of the current grid is AC. But many of these renewable power sources is actually DC. All of you have seen the photovoltaic cell. It actually generates DC, and there could be a DC power supply system. So again, earlier when maybe 100 years ago there was the DC systems. But again, with these renewable sources coming in, there is again now a discussion. It has basically energized the electrical engineers that should we again go back to DC, okay? Because DC has advantages, and ultimately there should be, both. Since currently both are available in the grid, there are ways to convert AC to DC or DC to AC, and whatever is is your requirement. Now this basically shows an intelligent DC home. Why am I called intelligent? Because you have all the renewable installation on the top, the renewable photovoltaic cells which can generate power. Suppose that photovoltaic cell supplies the home, then you may have an electric vehicle that can be charged, and then there are several household equipments that can utilize this power. So this is basically called an intelligent home. So though the name sounds nice, intelligent, or all of us, there have been sessions where there was discussion that AI will solve everything, but somebody has to design the AI system. That is the place where actually you need qualified engineers. I actually teach some of the AI topics in my class, and so whenever I hear this statement that AI can solve everything, AI can solve, but it actually needs qualified engineers to design it. Okay, now given this energy scenario, there is a lot of challenges, because the solar is not available in the night, the wind is not available, whenever wind is not available, you need power. So the electrical engineers are actually having a challenge how to supply power to the consumers, and the power demand is increasing. And we don't want to burn the fossil fuel. So a lot of research is actually going on if we can store power, the battery technology, and other sources of energy generation. So this scenario has actually put a lot of targets, challenging targets, and the targets are a lot of research targets, and that it actually gives rise to opportunities for the industry, academia, and ultimately the administrators have to actually enforce them on the population. So lot of opportunities are there in electric energy systems, electric power generation, then transportation. We are gradually going towards more faster and faster modes of transformation. We have metro railways inside the cities. Then homes, buildings, and other facilities are coming up that are smart. We call them smart buildings because, as Professor Mishra told, we may even think of someday there is a zero emission campus. The industry and the manufacturing sectors are involved. There is a lot of data computing and communication, because there has to be communication between the different systems. and hydrogen ecosystem and renewable fuels, food and agriculture. So the point is everything has to be, thought together. There is requirement of management of water, the infrastructure and communities, negative emission technologies, that is, we need to generate technology that can counter the emissions, geoengineering, environmental monitoring. We have discussions that the environmental subject should also be there in the curriculum, and then ultimately socio-technical systems, and ultimately the society has to be managed. Okay, because if these things are not properly managed, it can even lead to, social unrest. We are already seeing the weather is changing. Even there can be unrest between countries because if these challenges are not met. Okay, if you have noticed, we all see in the newspaper in winters there are, in Delhi there is a lot of fog, and it is attributed to that burning of the stubble, and so it is agriculture. It is an agricultural waste which is burnt. But again, our neighboring country is disturbed. This time they raised an issue that our country is getting polluted because of this pollution from India. Okay, similarly, we see some country makes a dam and for their own purpose, but it affects the countries downstream. So there is a socio-technical issues are also involved when we think of this energy and climate. So all this pollution, suppose in India, it is not just attributed to India. We are facing the storms, and which is coming over the oceans, and basically it is due to the pollution of other countries also. So the socio-technical things gradually are hugely involved. Now, in the broader perspective, we basically need a sustainable economic growth. Lot of research has to be done, but ultimately we need large-scale deployment and education and awareness. As Sir told that, the NEP 2020 actually offers a way to introduce some of these topics in our curriculum, equity and social justice, and ultimately it needs transdisciplinary collaboration. It is not that only electrical engineers is required. You need all branches of engineering, sciences, the requirement of economics, everything, finance, everything is needed, and ultimately it has to be collaborated to have a satisfactory solution. Now these are some of the targets. There are some short-term opportunities, there are medium-term opportunities, there are long-term opportunities. Short-term it could be power electronics for renewable generation. Those of you who are electrical engineers, large-scale renewable energy generators, batteries, fuel cells, emerging powertrains, energy management for data centers, intelligent microgrids and demand response, efficiency and green transitions, algorithm optimization. All of you are, do some sort of a coding. Ultimately, it is some algorithm is running in the background, and so software development, implementation in the hardware levels, electrolyzer systems for green hydrogen production, coordinated uninhibited vehicles for land use, and all of us know that the electrical vehicles are coming up, which is once the cup.
Dr. Dev, I would like to request you to sum it up.
This is my last slide. And then we have medium-term opportunities like dynamic energy pricing, if the pricing can be controlled, deep integration of renewable storage and demand management. So these are some of the medium-term opportunities. Similarly, we have long-term opportunities like greenhouse gas emission monitoring. If we can capture that greenhouse gas and storage and utilize for required for utilization, if we can have networked hydrogen hubs, artificial photosynthesis systems, and so on. So that was I wanted to submit as my talk in this energy conclave.
Thank you, Professor Dev. I think you can take your seat.
Okay.
Your points are well noted, and I will come back to the topic with respect to you shortly. But it's now turn for Mr. Swroop Mohapatra. He actually represents the Electronics and Computer Software Export Promotion Council of India. Mr. Mohapatra brings a wealth of knowledge in green IT and its role in reducing the carbon footprint of the technology sector. He will discuss how emerging technologies can align with sustainability goals and contribute to energy efficiency. I think.
Thank you, Dr. Mishra, and thank you for the great presentation, Professor Dev. Let me start by asking the audience a question, just to make sure you're not sleeping. What do you think an average human being consumes in terms of energy? Let's break it up into your brain and your body. Anybody? In terms of watt, how many watt does your brain consume? Anybody? Okay. Your body in a day? Come on, you can work it out, right? What is the average calorie consumption? The previous panel mentioned about food. What is the recommended calorie intake per day? Yeah. So convert that in 24 hours. So you burn that in 24 hours. Okay. So an average, obviously, human being consumes around 100 watt per hour. But the brain is a very evolved biological machine. Yeah, it just takes 12 watt. The reason why I'm saying all this thing, because I'm an IT entrepreneur, and obviously an additional responsibility of being the convener for Odisha chapter, Electronics and Computer Software Promotion Council. For us, we consume energy, and resources for us are obviously human capital we have here, and energy for our machines, and obviously energy to keep our machines cool, both the humans as well as the AI machines that we use. And we are mandated by the government of India to help improve the software export from $240 billion currently to $500 billion in 2030. And while we increase export, we have to be conscious about how we are consuming energy. So my intent here is to take you through what EAC does. I'll try to keep it within 10 minutes, hopefully, because I want to focus on the panel where we'll discuss the point. So just quick introduction about EAC. So EAC is the mandated body under Ministry of Electronics and IT. So we are the registration agency for electronics and computer software companies. We also are the agency that helps get you incentives that the government of India rolls out to exporters. And I know jobs is what we need, but IT as an industry has traditionally always sold to outside India, because unfortunate part of India is a developing country. So 90% of India are not actually the target of technology company. And the 90% India who are targeted, actually the data is targeted. I know I'm an AI entrepreneur. So what you are using the product for free, your data are being mined, and that is obviously a concern. So the 90% of India who use the product, they, the data is being sold out by the country to outside India companies who roll out all these apps and all. But these are the category of companies who we want to create, help, and become a contributor to the export. This is a long slide. What we do, I'll focus on 3 summary points. I'll focus on how we help in trade promotion. So you get subsidized booth charges if you're an exporter. You get access to specific India pavilions. So you become part of India companies who are exporting, and we give you networking exposure. But the whole intent behind is to actually get conversation flowing, because we've been hearing about AI and all those things. The only advantage we have as human beings is this human connection. So if all of you are here on a Sunday morning giving us your time, I will request you to give your attention as well, because your time without the attention is wasted for you, okay? And the time and attention you're giving here, the collaboration that we hope to build among academia and the industry will help us create an economy which is going to, deliver the next set of jobs that you are looking for. So you try looking for a job right now in IT industry. Those days are gone that you pass out with a degree and you will get a job. I know because our rejection ratio is better than Google. I'm very sorry to say that. We select 1 in 1,000. Okay? So you can imagine the number of people we reject to get to 1 person we hire. And I sincerely hope it's going to be better. So the attention that you're giving here, the discussion you're going to have, because you're having a shared experience here, all of us are aligned towards making India a developed, a Viksit Bharat, and increase export. This is what we are going to get you. Ability to network, and you can promote your company in IndiaSoft, and this is what I would request, Honorable Vice Chancellor, I put in the request as well. Academia should actually put in booth where you pitch for business, for research grant, and opportunities should be given to students to actually create use cases. And I'll request people from all branches to actually be hands-on, because degree nowadays has no value. This is a means for you to get a degree. But what you do to get that degree, move 20-80 with 20% practical and 80% theory to the other way around. 80% should be practical and 20% theory. Bulk of your time should be spent in actually installing software, doing that, and create those micro solutions. Have these hackathon boot camps, boot camps and all that we see colleges outside Odisha doing. Select the best use cases, and the college would allow the students to sort of go out, present themselves proudly, the solution that you have built for world. Yeah? Don't be a consumer, be a creator. That's the only way you can deliver value. Otherwise, we'll be talking about people has resources, consumes 100 watt an hour, what am I getting, salary. So 10% of our cost as a company is energy cost, right? In terms of electricity. For me, that is a resource I consume. But rest 70% is salary that we pay to people. Yeah? So I would hope that you get all the skill building through some kind of a capsule courses. So this is an example of a course created by Ford School of Management around export and all. I would urge BPUT and the colleges under BPUT to look at creating industry-specific courses that can be given to students. So this should be capsule courses, just not like a full degree course and all. But these are the things that will help you bridge the gap between what you are being taught in the book and what is expected by the industry. Okay. This is what is the next step. I'm not sure finish on time, but if there are any questions regarding EAC, I can take it now. If it is a panel, I'm sure Dr. Mishra will manage that. Any question about EAC? Okay, thank you. Thank you for your time.
Thank you. I think we'll pose questions to you once we finish up with all panelists. So may I now request Mr. Bibhu Charan Swain, a senior consultant and energy auditor at Powertech Consultant. Mr. Swain has hands-on experience in energy audits and management. He will provide practical insights into energy efficient practices and discuss how the higher educational institutes can implement these strategies on their campuses. Actually, we are planning to have a COE in collaboration with Powertech Consultants shortly. It is under consideration. So probably Mr. Swain would also like to tell about that particular venture. So let's hear from him.
Good morning everybody. It's a pleasure to talk to you on Sunday morning. I'm very glad that I'm speaking to all of you in a regulating universities who are going to affiliate number of engineering colleges. So perhaps whatever insights I'll be sharing with you, it will be more meaningful and practicable. Now, as far as I am concerned, I have graduated from IIT Charan, and I did my master from IISc Bangalore. My seniors, Dr. Nayak sir is here, and I'm very glad to hear Professor Alok sir presentations. Now, I'll start from where Professor Alok sir has closed his presentations. I'll try to have a practical experiences how we can create skill development within a period of 4 years. So basically, we are into energy audit, energy efficiency, energy management. We are also into renewable energy studies. We are empaneled with Bureau of Energy Efficiency of Ministry of Power. And you plan or name any industries inside Odisha. There are client. We did or we used to do certain assignment for them as far as energy consumption reduction, bringing energy efficiency, adding renewable energy, and helping them to combat climate change. Energy and climate both are important. Why? Friends, we hear about global warming, but it is not global warming, it is global boiling. Professor Alok sir have told you what are the adverse impact of climate change. Now, who is responsible for that? It is energy use. Now, CO2 is the emission of CO2 is the very highest as compared to other GWP potential or other GWP matters. So, even its GWP potential is 1, but CO2 emission brings climate change. Now, who is responsible for CO2 emission? It is energy. If you see the facts, 570 million TOE. What do you mean by TOE? Ton of oil equivalent. If you burn 1 ton of oil, you will get 1000 kilocalorie per kg is the GCV of oil. So you get 10 to the power 7 kilocalorie. So 1 TOE is 10 to the power 7 kilocalorie. Now by 26-27, it is expected that we will be in the 1500 million TOE. That means our energy consumption is not going down. That means your CO2 emission is not going down. It is not about electricity. It is about thermal energy also. It is about burning fossil fuel like coal, gas, oil. And from 8.1 billion, we are going to increase our population to 9.1 billion by 2050. As presentation of Professor Alok sir has just now presented. So my point is that we are not able to cut down the energy consumption. So what is relevant for us? To have energy efficiency or energy conservations. So which we call it as fourth fuel. Fourth fuel means energy saved is energy generated. If you save 1 kilowatt hour of energy, that means you are able to generate 2 kilowatt of energy because of that 50% loss. So students, today I'll just bring what are the technology are available, how we can bring that engineering asset, design assets inside our 4-year journey, and if it is really helpful, can we become an entrepreneur by focusing on those technologies, by manufacturing those technologies? Gone are the days, I believe, by going into software, by going into services institute, by taking up service-oriented career, by going to designing, it perhaps will help our country as Vikasit Bharat. We need a real manufacturing hub inside our country. And perhaps we may not be able to beat China, but we need to adopt China and bring that kind of manufacturing facility inside each colleges, inside each engineering institute, inside each state. So if you can. Now, why we do energy audit? These are the benefit of energy audit. You name it. Preliminary energy audit. I go walk around the colleges and target energy audit, detail energy audit, monitoring and verification audit. So these are the energy audit which is required to achieve energy efficiency. Recently, we have signed MO with OUTR, and we did all the government engineering colleges energy audit. We could bring reports by reducing 5 to 10% of energy use, and these studies has been done by the engineering students. So that is more important. And today we have a course curriculum known as BTech in electrical engineering. But my friend, Mr. Professor Dilip is there in Vellore. He was talking last week that we are offering BTech with specialization in energy management. BTech in energy management. Now, just imagine, after ITI, we promote a skill development course. 2 years, somebody went through a ITI course. Then whether there is a need of another skill development of 6 months, Professor Nayak was suggesting. Now you spend 4 years here, again you require another skill development course here. Why that skill development cannot happen inside that 4 years journeys? Now you look at any medical college, they look into the colleges, study, and second half they go to the hospital. A hospital has to be attached with a medical college. But can the regulating or affiliating university, BPUT, I request, appeal to VC Sahab if he's here, then can we allow a college, engineering college to run if he has tied up with any industries or any institute or any R&D organizations? So that we don't need any skill development course after this 4-year journey. We should be doing practices after coming out of these colleges. A doctor never go to a skill development college or institute anymore. He, after passing out, he go to a practice, doctoral practice. I was just discussing with Professor Manak sir recently that I just tried to share that. That means that possibility is there. What we did, we teach. Now, these are various technologies which professor used to teach you. Now, whether it is OM practices, inefficient equipment systems, now you study it. Now, our duty is to take you to that journey, show you that equipment, show you the portable instruments, and you try to manage it and do that engineering inside your campus. How it is possible? If you go to NLU, National Law University, which is in Cuttack, each semester, after the semester break, they used to go for 1 month course or 1 month internship in any of the colleges or any of the institute or any of the industries. I got one student from NLU who was a topper of that first year semester. He came to us. Now you imagine a NLU student working with us, a engineering consultant who are into energy efficiency or energy audit on regulatory issues of power. What he did, he studied 1910 Electricity Act, 1948 Electricity Supply Act, 2003 Electricity Act. So he combined, made a research, he got a very good appreciation, and we also learned from him. So that type of, and who was he? He was a first year law students. So I appeal, if a 6 month, you get 1 semester break of 1 week. Now can that 1 week, you should be affiliated with any of the R&D organization or industries. That means you take up that career, and when you passed out, you become a BTech in energy management or renewable energy or carbon capture with a specialization. So jobs will be plenty, but leave out jobs. I rate the success rate of a college or university or any engineering college, how much of entrepreneur they are creating, how much of money or revenue they are bringing while each student could bring revenue to that college. Assume 200 students are there. That means they can bring lot of revenue to that colleges, and assume 20 faculties they are there. With 5 faculty, around 10, or we are a 20-person company. Now if you can, we can bring 2 to 3 crore of revenue. Imagine 20 faculty in any department with so many students, how much of revenue with so much of facility they can bring. So this will definitely cross-subsidize the education fees, investment, also it will bring value to the colleges, and also it will create more number of entrepreneurs after the one they pass out. So if you come down to the next slide, now these are all theories. Now where it can be applicable, I'll just showcase. As an energy efficiency company, ESCO, we call it Energy Service Company, LED, air conditioner, energy efficient motor, tri-generation e-vehicle. Can only i5 motor is the new modern era energy efficient motor. Whether we need to import from China, can it be manufactured here? Can we go into repairing of i5 motors? Next. Similarly, e-vehicle, battery management systems, battery or any particularly all if you see charge controller, earlier charge controller were bringing only from China. Thanks to PM Saab with IIT Bhubaneswar, IIT Guwahati and IIT Banaras. We did one program where we are an industry partner. Their mandate was, we got a grant fund of 2.65 crores and the mandate was to develop indigenously manufactured technology for charge controller and BMS systems. The project is still going on, perhaps it will come soon. That means this technology, what our IIT is developing with support of industry partner, that technology will be available to the entrepreneur who can just go and mass scale manufacture it. So these are the areas. Now in energy audit, now unless you are not involved in energy audit in these areas, for us bringing a technology will be difficult. Now we have instruments, measure it, understand it, then make some analysis in your college, then bring a report, then try to achieve that energy efficiency in those areas where energy consumption is very high. Now these are the technologies, friend, and these are all workable technology. I know a lot of colleges as are from here, we can run 1 month capsule course, maybe virtual mode, but request and appeal to the faculty to take these assets and tell your student to do certain projects on these skills. Now, energy efficiency cold storage, agro entrepreneurs discussing, lot of food wastage are being happening up. 5 tons cold storage cost you around 15 lakhs. Can it be manufactured with 5 lakh? It is possible. Similarly, VAM systems, a lot of big houses are manufacturing VAM system, vapor observation machines. It is a very simple basis with lot of industry around Raukla. It is possible, whether it is Khorda, it is Raukla. So these technologies, VFDs, installations, solar tube. Now we don't any good manufacturing facility in Odisha. And whether you import from Maharashtra or Karnataka or Pune, normally Pune is a manufacturing hub. I understand. We are not so workaholic or like western part of the country, Maharashtra, Gujarat or Karnataka. Eastern is deliberately or little bit slower. We can do it by little bit overworking. So these type of technologies can be really manufactured with our support of the industries and academic participations. Now friends, the business is huge. If you look into the revenue sides, I am talking about only energy efficiency ESCO business. It is 1,60,000 crore of potential is there. Now how many ESCO companies are there? 150. Look into 30 states. What is the capacity of Odisha? 1,50,000 by 30. It comes around roughly 5,000 crores. That means 5,000 crore of potential are there, and look into the engineering colleges, and roughly we could only capture into only 5% of the business. So 95% of the revenue is still there. So I appeal entrepreneurs, students, and you are really marvelous. Whether you are Gen Z or Alpha or Beta, but you are really marvelous as compared to the panelists here, and really you can venture into it. Good to please, you may take up AI courses, but kindly look into the manufacturing aspect of the product or equipment. That is the need of the country. That is the need of the time. So I'll stop here, or I'll just bring two more slides if time can. Okay, please. Now demand side management. As that Professor Dev Sahab was telling, DSM. You know how much of energy we are really wasting. He has given a figure of 1 lakh megawatt. I'll just recalculate it. I'll say how we are not able to predict our demand. Now you know, our demand is not a flattened curve. What we need, our machine, whether it is alternator, nuclear generator, they run the machine in a continuous rating and develop 100 megawatt each day or each time. But my load side demand keeps on fluctuating. In summer, I switch on the AC, in winter, I switch off the AC. So my demand, in night time, I run the LEDs. So my demand keeps on fluctuating. If you, this is a curve of one of the DISCOM in Odisha. Roughly 550 megawatt is the at night 3 o'clock. Then the load goes up to 917 megawatt. Then again 960 megawatt. That means in one DISCOM there is a deviation of around 500 megawatt. If you look into SLT's report in the website, you will find in Odisha last year the demand has touched 7,000 megawatt maximum demand. Lowest demand has touched to 3,000 megawatt. That means there is a gap of 4,000 megawatt. That means we are not able to predict our demand. That means 4,000 of megawatt is being thrown and being added in the same day or in the same month. That means how much of energy is being wasted. That means how much of CO2 emission is going to the market or to the atmosphere. How much of climate change or global warming or global boiling is going to happen. So can a demand response by electrical engineering students or by engineering faculty, or we can predict what will be my demand tomorrow, accordingly I run my machine in a merit order dispatch principles. So that type of demand response study is required to be carried out. Now you take up any computer software programming, but kindly mix any project, any final year project. I appeal that this project has to be interdisciplinary. That means computer science, electronics, electrical, mechanical, all three, maybe civil, have to be clubbed. They have to be given one project, not electrical engineering group will be given one project. So if we can bring one type of disciplinary, multidisciplinary project, perhaps you will be creating value for the nation, value for the investment, what the state government is doing here, or what the central government is doing here. So you can take a snapshots, because I repeat, we are currently working on a project known as, these are the projects which we are working, and we require your support, your partnership. We are ready to sign an MOU with you, but we can give you the handling support, but knowledge-wise, you are the master. Being the researchers, you have that facilities. Currently, I am just cite one example. Industries, any steel plant, raw-class steel plant, they use coal. They use coke for their blast furnace. But there is a mandate by Ministry of Steel to go for green steel. That means they have to reduce their coke consumptions. So we are trying to design a machine so that whatever the raw vegetables or raw agro waste, forest waste are available, that we convert into bio coke. Coke is basically any fuel has volatile matters, fixed carbon as moisture. You remove volatile matter and moisture, you get fixed carbon, which is basically a coke. Now you put that coke, replace the conventional petroleum coke, you will get the same result. Now challenge is to how to make that coke. That means you need certain heating. So what we are developing, we initially burn certain fuel, combustion technique, we got certain biocoke. One of my new startup is doing that. But then we thought of, again, we are not adding combustion, we need to have solar energy for that. So we have to develop a solar panel, get electricity. Now we want certain heat. Now how the heat will come? It will come through an induction coil. That means I need certain IGBT, solar energy and induction coil, so that I can achieve that 200 to 300 degrees centigrade, so that the volatile matters and moisture will go out. What I will get? I will get a biocoke. That means that collaboration, IGBT, I need certain technology from the electronics students. I also need certain technologies from the chemical engineering students. So if we can club it, definitely we are going to make sustainable steel a good practices. So these are few examples how we really can work together and for the development of our country or our state. And I need your support and in that, and definitely these are skill development institute inside the campus within that 4 years journey. These are the technology you can develop. Next. So these are the various areas which Professor Swroop has really described. So I am not repeating in that you know that. And these are the various, we have recently, I just one case studies, we developed a startup known as Firings. Four students of second year, they joined us. They got State Youth Innovation Award, received the CM award from Honorable CM and 2 lakh cash prize. And after passing out, they departed, took one job. Then after that, again, 2 entrepreneurs has created similar kind of startup known as One Vero, which they got around 10 crore of funding recently in the Make in Odisha conclave. So that type of, and it was done by a private engineering college, not a very famous college, but the students used to be genius, then only startup can really, and I can give certain equity, we can give, to give student as equity, and we are developed a public company for that type of R&D. So you can take benefit of student particularly, can benefit of those facilities which we have. I hope we will take up what are the insight I have shared, discuss with your faculty, discuss with principals, and I also appeal the management of BPUT to make the curriculum so that we have one must internship session inside in each semester, and the student really need to attach with at least one organization so that they can get dual degree of electrical engineering with a specializations, so that they don't have to look for jobs, jobs will look for them. Thank you.
Thank you, Mr. Swain. Actually, we have learned so many things from you. I can assure you that BPUT is on the path that we have already changed our syllabus with the able leadership of our Vice Chancellor. He has actually invited, few months back, he has invited industry people to revise the syllabus, and it has come up with a very different, and actually we have provisions for industrial training right after the 4th semester and 6th semester, and an entire 8th semester is now devoted for the internship, where the students can go to, they do not have any other subjects, they can go to a particular industry and they can be evaluated by the industry people itself. So it's a, I mean, it's no more the old pattern kind of things. Certainly things are changing, and actually you have rightly also touched the issues like energy audits and particularly integrated energy efficiency system. That is very important, that IES model that he is talking about. And particularly students, it would be very useful, particularly the students from, I don't think it's only restricted to electrical engineering, because the topic that is demand side management is a very upcoming topic where all engineering branches can take up, because it's all about prediction. Okay, so the behavior has to be studied and it has to be predicted. So all the AI techniques we are talking about can be used for predicting such things, and we can really take many things out of that. So coming further, I think to our next panelist, Professor Manas Ranjan Nayak. Actually, let me introduce him. Manas Ranjan Nayak has a very beautiful combination of both industrial as well as the academia. So he has experience from both this area. He was there with OHPC, Odisha Hydroelectric Power Corporation, for a long time. And then he switched over to academia, and now he's a professor in electrical engineering. He does his research in this particular area. So we have with we have him in this panel, so he can really touch upon many points concerned to this. So over to Professor Nayak.
Thank you. Good afternoon to all. This is a very good occasion where we can discussing regarding the betterment of our engineering colleges and students and also faculty members in association with the industry. And I think I am lucky having experience in both the sectors. And before coming to this academic sector, I have worked in the industry sector, particularly in the energy sectors. In Odisha Hydropower Corporation Limited, at Indravati Hydropower Station, having 600 megawatt, and Rengali Hydropower Station having 250 megawatt, which are under the Department of Energy, Government of Odisha. And here I have already listened yesterday and today the panel discussions. Here I have already discussed many things with the engineer Bibhu Swain regarding how to change how to mitigate the gap between the industry and the institute. Is there any necessity of collaborating the industry with the institute? Yes, I think this is my suggestion. So there is a huge gap between industry and institute. Because I have already worked in the industry, I am also working in the academy. So huge gap. And we are not trying to fill up this gap, but we are telling, industry are telling our students are unemployed. Why our students are unemployed? They are completed project degree or 2 years management degree, and passing out this university or institute, they are unemployed. And we have to think that statement and how to create a platform so that our student will not be unemployable at industry end. And industry, when our students are going to join in the industry, after they are giving the assignment to our students, and after 2 or 3 days or 4 days or 5 days, they are telling our students are unemployed. It should, I think it should not be, because at our time, when I joined in Odisha Hydropower Station with the Hydropower Corporation, I have taken training at Odisha Electricity Regulatory Commission for 1 month regarding the different electrical act or statute, whatever is published by the Government of India and Government of Odisha, and norms. They have taught us for 1 month at Odisha Electricity Regulatory Commissions. And nowadays, time is so fast, no industry is interested to give training to our students at their end. And they are telling our students are unemployable within 5 days or 6 days after joining in that industry. And they are also telling we have no time to train the students at our end. You train the students as per our requirement at your institute. This is now the trends of the industry. So that is good, not difficult task for the institute, but industry should support to the institute in that regards. So I have some submission to the industry. In the many industries, in the manufacturing sector, they are using equipments, and some equipments are unoperational or damaged, and they are keeping that equipment in their store and selling that equipment as a scrap. So they can provide that equipment as donation to the institute, so that our students can see that equipment at the institute. And it is not possible for the students of the affiliated college or constituent college of this university to go to the industry frequently, because you know that our syllabus is very tight and it is very difficult for us to complete the syllabus in time, and there is no time, there is no scope to send the students within a semester to send to the industry. So during the study, they can also physically visit the different equipments which are used at the industry, and that equipment which are unserviceable or in the damaged condition, that equipment they can send to the institute for the equipment can be used by the institute and they can keep in the lab, and a student can also see that different types of equipment which are used in the industry. And second thing is, the industry nowadays, you can see what is the objective of the UGC, and there is a notification by the UGC, so a university can appoint professor of practice, so in the institute level. Why? Because the UGC wants the field engineers or professionals can come to the institute and give some knowledge regarding the industry to the institute. That is the basic concept. So here already I have already discussed with the engineer Bibhu and Swain regarding this. So here when you are going to give the affiliation to the institute, also in the apex body like AICT or UGC, they can think. So when they are giving affiliation, the Medical Council of India, when giving affiliation to the medical college, and they are giving the norms that if no hospital is attached with the institute, then that they are not allowing to run the medical college. Similarly, if the institute is going for any government or any trust is going to establish a engineering college or management college, so before establishing the management college, they should go for MOU or tie up with the industry relevant to their branch, relevant to their subject, so that this type of problem may not be arised. So the students and that industry can help to the institute, and also institute also collaborate with the industry, so that our students will be employable at the industry end. So there are different types of suggestion, or these are the points which can be debated among the academician and the industry personnel, in order to change our technical education system, so that finally our objective is our students should be employable and they can get the employment at the industry end. And second thing is, so nowadays the energy system is concerned, that there is already the panelists have already discussed regarding the requirement of energy. So there is a huge requirement of energy. All the students and the faculty members know it. That is not new to, and there is a emerging area where the research is required, and all the technical institutes and universities, they are trying, they are also doing research, because this is a mandatory requirements for the faculty members to do the research. They are doing, but there is a discussion at the industry, and the academician cannot solve our problem. There is a discussion at the industry end.
So Nayak, we have a little bit shortage of time, so
yes.
Can you please?
And last day, yesterday, our Raulkela Municipal Commissioner, he has pointed out the right thing. The problem statement should be decided by the industry, not by the institute. He has rightly pointed the problem regarding the problem statement. The problem statement, along with the required data and the required constraints in the industry, that should be submitted by the industry to the academicians, and academicians having the software and also manpower and the PhD students are there, MTech students are there, BTech students are there, having huge amount of the human resources with the faculty members. They can do the better research. They can also solve the problems of your industries, and also that will be helpful in future to the society. Thank you.
Thank you, Professor Nayak. I think your point is well taken. That is the way the medical colleges are attached to a particular hospital, and only when a hospital is attached to a medical college, it is given the permission to start a college. In the same way, engineering college can also be given permission to start when it is attached to a particular university. I would like to request our Honorable Vice Chancellor, sir, this is a brilliant idea, that unless until a particular college, engineering college or a university signs up MOUs with a particular set of industries, only then the affiliation should be given. By that, automatically it will be an automatic process. Okay, so I think this is a good point he has raised. Now I would like to pose certain questions to the panelists as well as the audience and the members who are present of the dais. Particularly, let me start with, because one of the aims is that by 2050 we should have a carbon-free campus. Because I am only telling this from the context of this SDG. What role can universities play in promoting sustainability and reducing carbon footprints? So this is the question I think Mr. Mohapatra would like to answer.
I think I'll start by saying that university have to think like companies. Right now, what is happening is that we've been mandated to give theoretical concept and the knowledge. The moment you start using sustainable technology, you will become a contributor to prevent climate impact. Second thing, what will happen is students who are trained on just the theory part of it can actually use solutions from the industry, from or by making add-on solution. Mr. Bibhu suggested a lot of potential solutions. Students could take it up as a project to contribute into the entire supply chain, starting from energy creation to energy consumption. And when you start using it, it's just like, before you feed somebody else while you're cooking, you taste the food, is it good or not? Right now, what is happening is that you just pass out with a degree without, and these are all vague, abstract concepts right now we're speaking. Because I remember when I was in your side, on the audience side, in NIT, Calicut, or XIMB, it used to be very vague, because the unfortunate part of it is that there is no way I can transmit my knowledge to you through my voice, and you're listening and you'll get the knowledge exactly like the way I intended to. There is a transmission loss. But moment you start doing it yourself, moment you start putting in the sustainable IT practices, could be something like a virtualization, cloud computing, again vague, but let me put a parallel. Nowadays people are staying in flats, okay? So why? Because there is an advantage of security, share resources, plumber comes, individual houses are costlier, okay? So the same concept is being replicated in the IT industry as virtualization technology. So you have multi-tenant setup, okay? So within a tenant you have privacy of data, but you use share resources from the hardware standpoint, the CPU, the RAM, all those things are common, and you create a VM instance out of it and you use it. Just like in a flat. So you go inside your home, but the common lift, common thing. So those kind of a virtualization technology, when you start using in an university, and you become the people who manage it, you can take external consultants if needed, but you're the one who use it. I remember in NIT as well as in XIMB, we used to actually run the certain part of the college's requirement, and that gave us a head start. So there is no reason for BPOT not to be able to even do it. What is required is the intent to do that. So again, like I was saying, 2080, move into 80, where you start practicing the sustainable IT. Because if you are doing it, like Mr. Bibhu said, you don't have to look for the job will look for you, okay? So you become job creator. The previous panelist was, moderator was saying about entrepreneurs not being created in India. I think it's very true. If you look into developed countries like US, 1 in 5 is an entrepreneur. So population of 330 million, 30 million are entrepreneur, okay? Sorry, my apologies, it is 1 in 10. But in India, the number of registered MSME is 6 crore in a population of 140 crores. So as you can see, there are not enough creators. And when you're looking for a job, I'm an IT entrepreneur in AI technology. We build product, and I can tell you, AI is coming for your jobs. There is no two way about it. So either you use AI as a job creator and become more efficient yourself, so that job becomes an option, not a compulsion for you, okay? So you will have the option either to earn and create jobs for others, or if you feel that no, it's getting a little hectic, I wouldn't deny, I've been a professional, I've been an entrepreneur, that's your choice. So use it and implement it.
Yeah. Thank you. Mr. Swain, please.
2050 carbon or net zero buildings. For us, this is the aim, but as far as the advancement of technology are concerned, this net zero building is possible even for BPOT and BPOT affiliated colleges by 2030. Recently, if you see, what is the energy? Electricity and some gaseous fuel which used in hostels or canteen. That is the what energy comes to the any educational institutes. Now, I am a SAC member, State Advisory Committee member to the Honorable OERC, and in OERC we have developed the rules regulation for net zero buildings by GNA model, group net metering, virtual net metering. That means even if BPOT wants, they can avail electricity from April 2025 onwards. They don't have to make any investment. By virtual open access, they can avail from large-scale solar plant and run it here. Currently, BPOT is paying 6.32 rupees per kWh to TPWODL. By availing electricity from any open access solar generator, they have to pay only 5.50. State saving of 80 paisa, and almost 80% of the energy will be net zero. Similarly, all affiliated colleges of BPOT, they can become net zero in 2025 also if they intend to. And regarding, now in case of Nayak rating, also kindly see that energy audit is mandatory and you give certain credit, mandatory credit, and also opening of energy club in each colleges, that has to be certain mandatory credit. Now it is possible for you to become net zero, and if you see currently MOP regulations, all commercial buildings are treated as energy intensive industries. Government of India, Ministry of Power, they give you carbon credit for adopting that net zero facilities. Now you can appeal to MOP, maybe through us or to directly to Bureau of Energy Efficiency, treat each colleges as energy intensive industries and give them that incentive which is allowable under Indian carbon credit mechanisms. So by adopting net zero, you will get certain incentive, plus your running cost of electricity will go down heavily. So these are the few takeaway, and currently we are going to sign term sheet with KIT. They will be going net zero by availing 20 megawatt of green power from a solar generator. Already all the rooftop has been electrified through solar energy. Similarly, in all the engineering colleges in BPUT, you can have a rooftop. Whatever balance is left, you can avail electricity from GNM model, VNM model, OA model.
Thank you so much, sir. I would like to request our Honorable Vice Chancellor, who is here, to set few points on this point, because it's a, sir, it's a requirement actually to have all the campus, including BPUT and all our affiliated colleges, should be net zero carbon. So we can make a policy so that they will be come under this particular act, and we can go forward. So this is one of the takeaways of this panel discussion, that we should, because ultimately as per the SDG, as he said that, Mr. Swain said that by 2030, we have to have this particular mission fulfilled. So would you like to, sir? Okay, sir. Okay, any more questions from audience? Can you please? We'll take one more question from audience.
Good morning, all of you. I am Mustivachan Panda. I am from GIT Badinatangi. As an electrical student, I want to ask one question. Nowadays, we are going for renewable energy sources like in the building or commercial purposes, also in e-vehicles. But I think after 5 to 10 years, we will have a big problem on the waste management of batteries. So what the measures or research that can be done in institute levels so that we can have a proper waste management of the electrical batteries, storage batteries. And my second question is, in your work for research work, we are working like day-ahead market predictions. For the demand side management, day-ahead market predictions, scheduling we are doing, that now we are doing even for 15 minutes prediction. So as the predictions are already considered, already done by considering the different political parties, their conventions or any other strikes or all things we are considering. Then also why there is a huge difference in the day-ahead market. There is a gap of, as sir told, 4,000 megawatt, 4 megawatt or 4,000 megawatt power gap in the highest peak and the lowest. So why these are happening?
Professor Dev, would you like to answer this?
So, Mr. Panda, I think your name. So I want to answer your first question, like you told that waste disposal batteries. So batteries are actually for, as an electrical engineer, so far all of us enjoy power. Whatever power is generated, we have to enjoy. Okay, so this light is on, and at this moment it is some fuel is burned, it is enjoyed, or some, in some idle plant, water is falling and generating power. So batteries are meant for storage. So disposing of batteries, okay, though that will be, matter of research, and people are going on what to do with all those electronic waste. But there are other ways by which you can store power, like, suppose there is a solar generation and there is a surplus power generation, you can use that power in the daytime. You can, in fact, you can yourself do, even at a small scale, at your own level, local level, like you can, if you make a policy that you will charge your mobile only in the daytime, that means you are basically using solar power to charge your mobile or laptop. Okay, and if all of us does that, it is surely going to save some fossil fuel. Okay, so, but that is also charging battery. Okay, you are charging your battery only in the daytime, and every day you make a policy in the daytime you will charge your battery. And basically somewhere some solar power is used to, suppose your campus becomes a green campus,
it may happen after 5 years. So then by what you are actually doing is, if all the students follow that, you are basically using renewable energy and storing it in the battery which you are using for 24 hours or more. Or it is not that always that big batteries have to be used for disposing of. So that is a larger picture. Other way power can be stored is, you can use that power in the daytime to pump water. Okay, all your tank filling can be used in the daytime, and power can be used, filling up overhead storage tanks inside the campus, in the localities. Okay, so that is why, this conclave, it also needs the administrator people to take all those major decisions. And if any emergency happens, then you use the power at night. But whatever possible, if that is part of planning, whatever is being pumped in the daytime, that is sufficient for the 24 hours and so on. Similarly, there is another scheme, in ideal power generation, which is called pump storage scheme, where, in the daytime the water is pumped and stored at a height which is used for generation in the night time. Okay, so far as material reuse or electronic waste, that is one thing, but these are some of the approaches by which you can think of, efficiently using the battery also. And in your small level, you can even, from today you can start with your mobile. Okay, just charging in the daytime. And then you are contributing basically to saving of fossil fuel. And what was your second question?
Why there is a gap in power
prediction.
Yeah.
Prediction. Yeah, so that is surely going to happen because, there is, the customer behavior is also changing. The customer behavior is changing, so the power companies are, whatever the power demand was last year, all those curves are available. So it may not exactly match with this year. Okay, the customers are having different types of gadgets, they have their own operation schedules, so there will obviously be some mismatch compared to the previous data.
Mr.Swroop would like to add something. Yeah, I'll just add into what you said. So in technology, I'm not sure whether you heard about the term of auto scale up and auto scale down. So moment there is a requirement from consumers for digital technology resources or whatever it is, containerized application will call these virtualized resources and automatically start spinning up new instances of their own to meet the demand. Okay, and IT, as you know, is a consumer of technology. You need electricity to run these machines and all. So suddenly, the utilization of energy will shoot up. Moment, let's say, whatever, could be festive demand, Amazon shopping days, whatever it is. So it is, earlier what used to happen is that it is just human being consuming electricity. And machines were dumb, literally, okay? So it is physical machine, dumb machine, known it will consume 100 watt an hour. Right now, these are connected, machines in a clusters, multiple clusters. They see demand, they will create instances of themselves and start consuming energy. So it's very hard to predict in a static manner, and that is where the need for a smart grid comes in. So standard protocols, standard communication rules, taxonomy like ONDC, UPI, this has to be set by the government. Obviously, again, I would look at BPOT to contribute. IIT Kharagpur, obviously, Professor Dev was mentioning that he has been invited to do so in Bureau of India Standards. So set the rules and get automated analytics done to solve this early identification. So moment you see demand is going up, right to the source, you have to start requesting maybe a connected small modular reactor to start generating more electricity. So right now source is like one static thermal plant, one maybe solar panel. So energy requirement goes up. You cannot suddenly increase the demand unless even the creator is also intimidated by a bot and new instances of a reactor is spawned up, if it is possible. I think you're the expert here, but yeah. So those are things that the industry can look at.
I will add two more examples, One is the objective is to enjoy power but reduce the fossil fuel burning. Okay, so even it can be taken up as small student projects. There could be a small student project where you use a light detector and then switch off the street light. Okay. Okay, so that, and if you to apply it to the institute level, obviously institute has to allocate certain fund and it can be just implemented. In many institutes, it is actually implemented. Where, and those even for purchase, those devices are available. Okay, similarly, in many places you will find, that in the hostels, in the libraries, it is implemented when there is a backend, the lights will go off. And so that is basically using the devices, IoT devices. It will detect the number of persons and it will switch off, it will operate the optimum number of lights. And it can be purchased, it can be implemented straight away in the hostel corridors, in the library buildings and in other office places. And you will see the effect once they are installed and when they are not there, and so that is implemented. As I told, in my IIT, it is implemented actually. In many other institutes you will find, and obviously it is a policy. And one more example. I just give another practical example, and maybe this is for the Vice Chancellor, sir. I was Associate Dean Electrical of IIT Kharagpur in 2023-24. Basically the entire electrical system was under me, and since I worked in the power sector, I enjoyed that work. So there, it is, in IIT Kharagpur, the solar installation is 10 megawatt. The solar installation, it is gradually being added. Now in the hostel tops, in the building, institute building, and now some cycle parking lots are made such that solar and below is the cycle. Some car parking lots are made like that, and the total installed capacity is 10 megawatt. And our IIT, once the full students are there, the consumption is about 7.5 megawatt. So these figures I know because when I was the Associate Dean Electrical, I was handling all these numbers. And if this solar is there in full efficiency, it is operating, then IIT is actually exporting power. Okay, so there is a net metering system with the power company. Once there is surplus power in the campus, it is not getting utilized, the power goes to the grid. And right now we also have some hostels where the entire kitchen is actually electrical ovens are there. We have got rid of these gas ovens, large hostels, 2,000 capacity hostel. So that is actually for the administrators. It will take time. It may, if you start initiate now, this entire thing can take 4 or 5 years to do, and it will need proper planning, estimation, some amount of budget allocation. Sometimes a budget is also allotted from the ministry, and because they are encouraging this green fuel technology to be implemented in the campuses.
Thank you so much, sir. I think the point you are making, I think Mr. Swain would be like to answer that perfectly, because he was talking about demand side management. So exactly that is the thing he would like to answer.
I'll tell you one thing. The question is very vital. There is a large deviation in the demand. 7,000 in the evening peak, 3,000 in the night of peak. Now, problem is that the technology are yet to come. Plus, sir has correctly told, there is a behavior. In night time, you require lights. In daytime, you don't require lights. So, light loads is really high. Now, plus the level of awareness which we are having. Now, currently, Honorable Commissions has approved a day TOD tariff, time of day tariff. That means if you utilize electricity for storing your non-essential work like pumping of water, in daytime you have to pay 10 paisa lesser. If you do it in the evening peak time, you have to pay 20 paisa higher. For us, that awareness is not there. That level of awareness has to be increased. Now, if we are recently, Honorable Commission has again doing a public hearing. For us, all the academicians can participate in those hearings. Now, if the TOD tariff gets changed, that means if you utilize in the daytime and you have to get a 50 paisa incentive, then definitely all the industries will switch on to daytime uses. They don't utilize the peak time uses. So by adopting a pricing change, you can bring that gaps. Plus technological interventions. Now just imagine you have in the auditorium how many wall fans are there, and I am sure these are not VLDC fan. With a 3 years or 2 years old auditorium, we should have VLDC fan instead of, this will be consuming around 100 watt. If VLDC fan was there, it will be consuming 28 watt. Now just go to your colleges, even in BPT campus, in hostels, for us we don't have any VLDC fan. We are still utilizing the 75 watt. So by state reduction of that adoption of technology, you will be saving 75 to 28 watt. That means roughly 48 watt of fan load will come down. Like LED, we are able to make that level of awareness. We have get rid of that yellow light, now white lights are emitting. So LED awareness level is there. VLDC awareness is not there, and government of Odisha with OERC, they have given 50% discount. 2 lakh VLDC fan is going to be employed. But as an academician or the knowledge partner, you need to encourage this level of awareness level among all the citizens, so that real consumer will adopt those technologies. And also you have to keep on developing the technologies to mitigate that demand response. Only studying demand response will not solve the problem. You have to bring the technology which can really minimize that gap. But that gap is still there. And coming to your battery replacement, battery as recyclable, and all the lead acid are being recycled. You go to Pakistan, they used to produce recycled battery. You have separate in, you can jointly collaborate, and they can do the plastic recycling, and you can do the lead acid. And also you have to have for aluminum water technology based battery. And currently Government of India with Ministry of Power intervention, with MOEF interventions, the State Pollution Control Board representative is not here, but he will be able to share that any new battery manufacturer who is coming up have to mandatorily take away recycled battery. That is a new regulation has come up. So it is a mandatory recycle policy has really come up.
Thank you. Your first question regarding the battery. So there are different storage devices are available. The supercapacitor, hydrogen storage. You can compare with the different energy storage devices, and then you will find which one is the better. And regarding your battery energy storage system, so all the advantages and other things have already discussed by the panels. One more thing I can add, you can think about the battery health management. So how to do the battery health management, that is very essential if you want to use the battery. And when you go for battery health management, so you know that how to use that battery, charging and discharging. So you know that there is a state of charge of the battery. You have to operate the battery within a certain permissible range, which is prescribed by the battery manufacturing company. If you go beyond above the range and below the range, that means your health of the battery will reduce, and indirectly the cost of energy will increase, because all the cost involved toward the system, including the renewable systems and your battery, everything includes towards the cost of the energy. Yes. So battery health management is one of the criteria. So in order to minimize the waste disposal and also reduce the cost of energy, that is a very vital one. Your second question, which I've already addressed by the engineer Bibhu Swain, regarding the your demand management. So normally our load pattern is not flat. Sometimes peak and sometimes off peak. And peak time is very less time compared to the off peak period. So how to manage it? Because power system operator has less control over the load. Because load is consumed by the different sectors are there, industrial sector, your commercial sector and the domestic sectors. You have very less control. You cannot tell that you can't use this energy, because there is an agreement when the customer comes to the office and he applied for the suppose 2 kilowatt load or 3 kilowatt load, 4 kilowatt load, and the service provider has to supply that much of energy, and as per the demand, as per the requirement of the customer he can use. You cannot say that you can't use. But that's why there is a mechanism. We have already submitted, published a paper, and also we have submitted a representation to the OERC in 2021. You can find my profile, the Scopus database, Web of Science database. We have published a paper which is told by the engineer Bibhu was saying the time of use. When the OERC every year, OERC is determining the energy tariff, considering the different factors, inviting the applications from the consumer side as well as the transmission distribution companies and also generating companies. Finally, OERC decide what should be the energy tariff, differing the different aspects. And here one thing is, so you cannot tell the customer you don't use the energy. You cannot tell the service operators, cannot tell, or power producer, they cannot tell because there is an agreement.
Professor Nayak, we are actually short of time.
So that's why, so policymaker has to decide the tariff. So in the peak hour, since the load is peak, so cost should be high. And off-peak hour, cost is less, your load is less, cost should be less. So that automatically the customer will shift from peak hour to off-peak hour, so that your load curve will be flat. In that way, we can manage the load.
Yeah. After this panel discussion, you can contact Professor Nayak. Okay, he will explain it thoroughly. So now we have come to. Thank you all. I think during the shortage of time, we are running short of time. So we have to actually conclude this panel discussion. I should thank all the panelists that they have extensively discussed the topic under a broader theme, that is sustainability, sustainable education for Viksit Bharat. And they have also discussed about the role of BPUT Odisha. So, and some of the outcomes of this discussion can be, we have actually identified certain actionable strategies for particularly about the carbon neutral by 2047. So we have to follow certain steps as suggested by the panelists. For example, regarding this, what Professor Deb started, that energy saved is actually energy generated. That's a very important point, and Mr. Swain has taken up that further, that energy efficiency can really be achieved. So we have to go in that direction, and our ultimate aim is to make the campuses, at least the campus, to start with, we'll start with our BPUT, and we can always tell our affiliated colleges to become carbon neutral. Then there may be some collaborative models for industry, academia, community collaboration, and that will definitely enhance the sustainability efforts. And we can always go for certain actions regarding skill development. So why to train a student right after the graduation? Why not during the graduation period? So that's a very important point we discussed, and recommend training programs to develop expertise in green IT and energy efficiency among students and faculty during their stay in the campus. And finally, we should have methods for technology integration, this renewable energy integration into our campus. So we have to identify these technologies that can be adapted by the higher education institutes to create smarter and more sustainable campuses. So with this note, I would like to thank all the panelists, all the audience who are present over here for a meaningful discussion in this morning. Thank you all.
Thank you. With this, we conclude the panel discussion on energy and climate. Today's discussion has highlighted the urgency of addressing climate change through sustainable energy solution. Now I invite Honorable Vice Chancellor, Professor Kumar to join us on the stage to felicitate the panelists. I request our Honorable Vice Chancellor sir to felicitate Dr. Alok Kanti, Professor of IIT Kharagpur. Thank you. Now I request our Honorable Vice Chancellor sir to felicitate Mr.Swroop Mohapatra, CEO and co-founder of Durba's Technology. Thank you. Now I request Honorable Vice Chancellor sir to felicitate Mr. Bibhu Swain, Senior Consultant, Energy Auditor, Powertech. Thank you. I request Honorable Vice Chancellor sir to felicitate Dr. Manas Ranjan Nayak, Professor and Head of the Department of Electronic Engineering, BPUT Raulkela. Thank you. I request Honorable Vice Chancellor sir to felicitate our moderator, Dr.Sivkumar Mishra, Director in Charge for UG and PG Studies, BPUT Raulkela. Thank you, sir, for your kind lecture. Here we come for the end of this session. I request all the delegates, faculty member and students to assemble in the amphitheater. After that, we will proceed for the lunch. Thank you all.